Everyone, my name is Hima, and yeah, I am a former machine learning engineer and lover of JavaScript and TypeScript. And today my talk will be on something that a friend and I created over the course of a couple of months. And it's pretty much a new way to make screen recordings, but with JavaScript. So, my story began originally when my friend and we asked ourselves, how do we create screen recordings today? And well, our obvious answer was, install some kind of desktop program like QuickTime or some kind of browser-based tool like Loom that lets you record your screen, and where the outputs are MP4 files, right? Collections of pixels that are frames, and these sequences of frames are create these videos. But we then asked ourselves, this is 2021. JavaScript is the best language in the world, and our browsers are our operating systems. And so, could there be a way to bring screen recording into the browser itself using just web like native primitives? And by that I mean using just HTML, CSS, JavaScript. Could there be a way to make screen recordings? And after some thought, we decided that yes, actually, we could theoretically just capture web pages only and capture the HTML DOM on these pages as they change over time. So as you're moving your mouse around, as you're clicking on buttons, as you're opening modals and everything, we can track all those changes to the DOM and record those as a pseudo video. So this might seem a bit strange at first, just by describing it. So I'm actually just going to do a demo right now, which should hopefully make this a lot clearer. So I have this random Google page open here, and here is the end result, which I'm going to show you right now. We call it capsule. And what I'm going to do is start a screen recording here. So I'm going to press this video button. And so now the recording has started. So now I'm just going to scroll down the page, this website page. And I could do a whole bunch more. I click on these links and such. But for the sake of time, I'm just going to finish the recording here. And after a second, a new link opened up with this tool. As you can see, it says the recording was 11 seconds. And you can see that it's actually scrolling down the page right now. So you're like, okay, this looks like a screen recording, but why is it different? So the recording has ended, but as you can see, I'm actually able to scroll on the page right now. If this was a normal like pixel video, you would not be able to do this. But more than just scrolling though, I'm actually able to do things like open these links on this page. And for example, all of these things are actually active links. So again, unlike a normal video where it captures pixels, what's happened here is that we actually captured the HTML DOM on the web page as I was using it. And then we are able to actually replay it here again. So I hope that makes sense to you guys. Unfortunately, I can't send the link to you to play with it right now, but I can send it afterwards in the Rambly later on. But yeah, so back to the talk. The rest of the talk, I want to talk about sort of more of the motivations behind this and how we actually went about creating this tool in the first place. So first of all, just what are some of the benefits of this HTML-based screen recording tool versus a normal like a pixel video? So one is that these again are interactive. You're actually able to click on all the links in the page and scroll through it as well. Another is that it's super low bandwidth. A normal video can be very intense because of all just the pixels and the frames and everything. But here, though, all that's being transmitted in these capsule videos are just is just text. The text being the HTML and the CSS of the website and how it's changing. And the third big benefit actually is that there's no rendering or compression loss. So again, in a video, there's often some kind of compression happening to make it smaller to stream. But here, though, we're just transmitting text, and your browser is actually re-rendering everything on its own. And so there's no like gradientness, there's no pixelation at all. It's all just perfect, really. And so besides that, here are some just more concrete uses of how you could use this kind of web-based screen recording tool. So one thing is that you can easily just show off a demo of some website. A use case I really love to use this for is that I can actually use this on localhost. So as I'm making my localhost site, I can record a new feature I just created, a new bug that I just fixed, and share it with my teammates, and they can just view the actual localhost changes without me having had to push first. And of course, there are some other really cool things as well, I think, like archiving the internet and sharing feedback on websites more easily. And one thing I do want to mention as well is that this sort of technology has existed previously. But it's only existed in things like Full Story. If some of you are familiar with that, it's like a analytics tool that records user screens. But the thing that my friend and I realized is that despite this technology sort of existing previously, it was never available in the hands of us, the consumers, the users of the internet. And so we really felt that this could open up more uses if it was open to everybody to use on their own. Okay, now the big question, how do you go about building this yourself? So here's just a high-level diagram of how our version of this works. So there are 3 parts to this. One is the Chrome extension, which I just showed you, and this is what actually records the changes to the DOM as you're recording the video. The second part is just the backend, just to store all the data and then allow for replaying the videos. And the third part is the logic for replaying all the DOM changes in the front end to create this video effect. So next, I'm just going to talk about these 3 different parts and sort of the technologies that went into creating this. So first, again, on the front end, which I think is one of the more interesting parts, again, with all the JavaScript there, we used a few key things here. The biggest one is something called the Mutation Observer API. So some of you may know this, but I think many of you may not. But the Mutation Observer API is an API built into our browsers. And it's really nice because it actually calls your callback functions whenever the DOM changes. So whenever a certain div changes, for example, you can receive those updates and then process those. So this is one of the main things that we use to get the changes to all the divs on a page, for example, and then process those and then save those. Unfortunately, this is not enough, however, because for things like input fields, those are not recorded by the Mutation Observer. So we have to add those separately ourselves, and then the mouse and scroll listeners as well. These are all additional things that we added on top in order to create the whole extension to capturing ability. And on the back end, so actually for the back end, we used Rust, but the backend language doesn't really matter here. But mainly the point of the backend here is to just store all the different changes per document. So by document here, I mean each web page. So in these recordings, you can go through multiple web pages and actually record each of them in a sequence. And per document, there are different changes. So a change here could be me typing in a text field, me moving my mouse, me clicking on a button. All these different changes are stored as well per document. And this is really important because later on, we'll have to be able to retrieve these changes and these documents and then replay them to create the video. Now, a big important thing here as well that I didn't mention before is that we actually disable all the JavaScript in the videos. This is mainly just due to security concerns because we don't want random JavaScript running and we're rerunning later on. And so only the actual DOM changes are recorded. And so because of that, we have to clean the HTML to do things like remove all of the JavaScript script tags and other things too, like convert relative to absolute URL so that things don't break when we're serving it from our servers. And the specific assets, like the HTML, the base HTML page or then CSS assets or the font assets, those are also stored by us as well, because an important thing here is that even if you record a web page initially, the actual URLs on the web page might go down or they might not be accessible later on. And so we save those URLs, all the assets, so that your recording is always going to work. Okay, and then the third part that I mentioned is the front-end replay ability. So on the front end, whenever you go to these links that are generated, the first thing that happens is that we retrieve the documents and all the changes from the backend for this unique ID. And then we have some logic that applies the changes one by one. So we load the first document, we apply all the changes, and in this application, the changes per timestamp, this is what creates the video effect. And we also used a very nifty library called MorphDOM, which has been used in a lot of other virtual DOM libraries as well. And what MorphDOM lets us do is that it lets us apply just specific diffs on the web page. So if, for example, you click on a button and a new div expanded, we can just apply that specific div expanding DOM change using MorphDOM very, very easily. And of course, there's just other more metadata and things to keep track of as well in the front end, like the timer, the play pause, day, all these different more minor things. But basically, though, those were that's the high level of 3 major components. So again, on the first part is that we use the Chrome extensions to record all the changes. We send them to the backend. The backend does some cleaning logic and saves the data. And then again, on the front end, Whenever you load one of the unique URLs, that's where all the documents are reloaded, and then the changes are applied to create the video effect. So there were actually quite a number of issues faced when creating something like this. And I would say like a lot of some of the issues really just come from how big the HTML spec is and how many just small edge cases there were. So for example, I had not actually previously known about this thing called the base tag, which lets you change the URL to which all of your assets are loaded relatively to. And so that caused some issues initially, but it was an easy fix. But there were a lot of these like really small things that can cause these issues. Now, some more bigger issues that we faced, one was, for example, sort of us just initially like thinking that, oh, because we have style sheets that are linked in the page in the HTML, we can just fetch all those style sheets initially and then save them and then just serve them from there again. But unfortunately, people do generate CSS dynamically these days using JavaScript. There's also like JS in CSS or CSS in JS, things like that. And so because of that, we also had to add additional logic to actually fetch all of the CSS from the page itself that's actually generated as well and track it over time too, instead of only looking at the original style sheets in the actual HTML. Two other big issues that we faced were iframes and canvas elements. So iframes are sort of tricky because they are loading an entire new web page within your web page. So we initially had support for this, but then they were still failing in some certain cases. So we decided to remove the iframe support for now. But you can definitely put in the effort to allow iframes to work though. Another interesting element that's hard, well, it's a bit tricky initially, but canvas elements, so canvas elements, they don't store actual HTML in them. And so they're much harder to track the changes to over time. You can track the changes, but you have to store the actual changes as images and then replay the images on the replay side. And so these were just a few of the technical issues that we faced. And I also want to just talk about sort of how we went about facing these bugs and problems, because some of these bugs were just very pesky and hard to catch. For example, we saw certain bugs only on some rare web pages because they had some very strange logic or some very kind of like misformatted HTML or something. And so those often required just going into those specific pages, trying to debug the actual CSS or some strings. And so that was interesting. Another big thing I think I learned though was that we had to change large sections of our code and logic at times, and that default implementations were not always the best. So on the back end, I mentioned that we used Rust. And one big reason why we wanted to use Rust was because the Mozilla Firefox browser is built on that, and they actually had a nice library for parsing HTML documents. And so we thought we could just use that, and that would help save us time. And so initially we did use this, Mozilla HTML parser. Unfortunately though, we actually ran into a lot of bugs due to that, because it turns out that on the web, a lot of web pages are actually not properly formatted. A lot of them break the HTML spec, but because our browsers are good, they actually try to fix the HTML to make it more correct. And while this is normally good for us as a user using our browser, this is not as good here when we're trying to track all the changes to specific elements. Because by using the Mozilla HTML parser, it actually changed the original HTML, which caused issues when trying to figure out where a certain change was applied. And so we actually ended up removing the entire Mozilla parser and made our own representation to store the HTML DOM along with some extra metadata. And that turned out to be much more flexible, but it did require building some things from scratch, but it turned out to be worth it. And my last sort of takeaway I just wanted to tell you all about today was really that I think that we're still underutilizing the web today. So what I showed you so far in this talk today was that we were able to create this way to record your screen using the web, using just HTML and JavaScript instead of pixels. And while there may not be as many solid use cases to this, because actually one drawback to our approach is that there are some times where we are not perfect and we misrepresent what's on the page, or something is missing from the recording, which is not very good. We want to have a real recording that actually looks perfect. So in a lot of cases, it's still true that you want to still do the normal pixel-based video recording instead. But there are use cases that we found just from creating this new kind of technology and making it available to just us as regular people. And I think that there are a lot of these different things that even 2021 that we haven't actually fully utilized the browser for. And I'm excited with more things like WASM and WebGL maybe that perhaps more and more of these things can be put into the browser, which of course there are drawbacks to that, but I think given how ubiquitous the browser is, that people can actually put in more effort to try to figure out these things that might help us even more in the long term. So yeah, so that was basically a quick run through of this project Capsule, where again, we were able to create screen recordings that were web native. Yeah, so if you have any questions later on, feel free to email me or contact me. But thank you, and thank you to the js.la organizers.